A force is a push or pull, right?
Push or a pull? Okay.
It's like
Yeah.
basically to
Say.
move object.
Good. Good. And Ruba, what is the force?
Push or pull upon an object when getting in contact,
Getting in
interaction
contact.
basically. Yeah,
That's a good
interaction.
point. Yeah, getting in contact. Okay. We will discuss this point soon, right? Okay. So yeah, overall it was a good feedback. Everyone was correct. Okay. So let's start with the discussion with the types of force, right? We will discuss okay, what is a force. So as everyone said, okay, a force is a push or a pull, right? And yes, that is correct. So if I choose color, okay. Imagine you have a box. Okay, why is it not accepting my input? Okay, let me change the color. So imagine you have a box over here and you have, let's say, a person standing over here. Let me call him Ali. Okay. Ali applies a force on it, F. So what would happen to this particular box? It would obviously move in this direction. Okay. Let's say Ali stopped applying a force at this particular point, right? And it stopped, right? So you can see that Ali applied, it basically applied a push, right? And that caused what? The motion of the object to start from point A to point B, right? So you can define a force as a push or a pull. That's a standard definition. If you have in your exam theoretical question, like what is a force, that is the enough definition to describe it. We had different types of forces, which we had discussed in the last chapter. So let's quickly skim what we discussed in the last chapters, right? We discussed gravitational force, right? And we discovered magnetic force and we discovered electrostatic force, right? Interesting factor about this is as follows, right? Rupa said, sir, force is a quantity which requires two things to be in contact, right? But we have gravitational force, we have magnetic forces, we have electrostatic forces, which are basically applying forces on each other, but they do not require contact, right? Let me just describe and draw some scenarios for you. Let's talk about magnetic force, right? We will discuss this in the future chapters on magnetism. Okay, so let's talk about magnetic forces over here. So let's imagine you have two magnets. I believe you have played with the magnets in your childhood, right? Everyone has. Imagine you have two magnets, right? And this is north pole of this particular magnet and the south pole. And let's imagine I have the same poles aligned, right? So what happens if you have like poles coming toward each other? What is the direction of
Sorry, there are a couple.
they repel, right? So you're gonna have a force in this direction, right? You will experience this force on your hands, right? Because you're trying to bring them together, but they cannot be brought together. They are you experience of a force on your hand, right? But what do you see over here? There is no contact, right? There is no contact over here. Still, there are forces, right? So if you talk about forces which involve motion, which involve basically motion like this, a person pushing up, pulling a box, or a car moving across a road. So yeah, that need a contact, right? But we have forces which does not require any contact, like magnetic force, right? Let's talk about gravitational force, right? We will discuss this in detail, and we have discussed this in the last class also. Let's talk about this gravitational force, right? It is a pretty interesting factor, right? Just imagine a universe which has been born from billion of years, right? Still, it is moving with the precise motion, right? Imagine this is the sun over here, and imagine this is Mother Earth, right? This is the Earth after Mars. Okay? Sorry, you have Mercury, Venus, Earth. This is Mother Earth over here, and it has been moving in this particular orbit since billion of years ago, right? So from billion of years, it has maintained this particular orbit, right? So what is the factor which is causing it to stay like this, right? That is gravitational force, right? So if you have two bodies, this is trying to basically apply a force. The Earth is trying to basically apply a force on Sun. That is called Fg. Okay. And similarly, the Sun is trying to pull the Earth, right? Fs. So this couple of forces exist without any contact, right? So you have also these type of forces which does not require any contact, right? So this forces is maintaining the particular orbit over here. If the Earth changes this orbit slightly to the, let's say if the orbit radius increases slightly over here, or if the Earth comes over here, right? This can lead to extreme fluctuation, right? In temperatures. Let's say if the Earth comes closer to the sun, Okay, let's say this is the position E bar. The temperature would reach hundreds of Celsius, right? And the life would not survive, right? Imagine if the Earth goes over here. Okay, let's say there is a meteorite which hit the Earth and it came over here, right? So this can make the temperature to go below 0 Celsius, right? And still the life would not survive, right? Just imagine the beauty of the God, right? And scientists, right? Scientists like Einstein, who do not used to believe in God. Scientists like Stephen Hawking, who was also an atheist, right? They started believing in God when they were basically at the end of their lives, right? Because when they discovered these principles, the perfection of the universe, right? They just gave, right? They did not accept any particular religion. They just believe that there is someone, right? There is someone who's controlling the entire universe and is maintaining the entire beautiful, you can say, balance of everything, right? Nothing is basically extreme, right? Earth is at a perfect position so that the life can be supported. Okay. And then we have electrostatic forces, right? So electrostatic forces would be done in chapter number 4, that is electricity. So let me just give you an example of electrostatic forces, which again does not require any contact, right? So this concept needs to be built over here. So forces can be between two objects which are in contact, and force can also be between two objects which are not in contact, like gravitational force, like magnetic force, right? And like electrostatic force. I'm gonna test your chemistry concept, right? Now, I want Maeve to answer first, then Ruba. Okay. Imagine you have a positive charge and you have a positive charge, right? And I'm trying to bring them together, right? Where would be the direction of force? Maeve,
Yeah.
can you speak loudly?
What is like it will move apart, right?
Would it repel or attract?
Like it will repel.
It would repel, right? Ruba, do you agree with Maeve?
Yeah.
Yes.
Right. So like charges repel. Similarly, they are not in contact with each other, and still you will observe this particular motion of the protons, right? They are repelling each other. They are moving away from each other, right? So this will be done in the future coming chapters. That is section 4.2, and we'll discuss this in detail. Okay, how does this force is created, right? There are some electrostatic field lines which we will see in detail, and how does this produce this particular effect, right? Okay, so as Ruba said, certain contact forces occur between objects that are touching each other. Yes, they can generate forces. Okay, so we have drag, right? We have air resistance, right? Imagine, let me draw my Bugatti. Imagine you have a Bugatti, right? And you're driving across the road, right? And obviously, when you're pushing, let's say you're moving forward in this direction, there would be opposing force, right? That will be air resistance, right? Whenever you have air, you will have air resistance. Imagine you're swimming, right? Imagine you're swimming underwater, right? Let's say this is Hamza. Hamza swimming over here. Okay, as Hamza is trying to swim over in this direction, there would be a force which will try to stop Hamza, right? There will be force of drag, right? So these forces basically leads to resistance in motion, right? So these are called resistive forces over. Okay, so anything, let's say, which is going through a fluid, right? Let's imagine if let's say a person is running, right? Let's say he's running in this direction. He would also face a small air resistance, right? You might have seen, let's say, if you're running or jogging or running, if you're running at a high pace, right? You would observe there is some air trying to slow you down, right? So these are all called what? They're called resistive forces. They try to resist your motion, right? So types of forces, you should be clear which are resistive forces, what are contact forces, right? And what is a thrust? Can anyone tell me what is a thrust? Raise your hand and answer. You have your answer on your screen right now in one of the diagrams. What is a thrust? What is thrust? Give me a guess. Yes, Varda.
सर एक ही डायरेक्शन में ज्यादा फोर्स लगाना.
Okay, good. Anyone else want to guess? Quickly, I want quick responses. Can be wrong, can be correct. No worries.
Sir, sudden force in a particular direction.
certain force in a particular direction. Okay. So thrust is just the push of an object, right? Okay. This car is basically having a forward force of F, right? Which is provided by the engine, right? The engine ने push किया है इसको to basically move with force F. Similarly, when you're moving with force F, that is the force provided by your body, right? So this is the thrust or driving force, which is causing the object to move in the particular direction, right? ठीक है. So how can we represent force? We can represent force using a free body diagram, right? So we know, okay, let's say if we are drawing a very good diagram, we can see my skills. Yeah, let's say imagine if you are a student of Picasso, you can draw such exquisite diagram, right? Let's say if you're not a good, let's say artist, so you can just represent using a free body diagram, right? What is a free body diagram? You just use a block, right? Let's imagine this is the car, right? And it has two forces, right? One force is basically causing it to accelerate in this direction, and one force is trying to stop it down in this direction, right? That is air resistance. So this is basically a simple representation of any body, right? Resistive force, air resistance, right? So does that make sense? Let me just give you an example of free body diagram. Free body diagram. Let's imagine this. You have this box over here, box here, right? And this person, let's say, or let's say this person is trying to pull this, right? Trying to pull this box in this direction, right? So the force applied to the box is in this direction, and there will be some friction, right? In this direction, right? A friction. So I can just represent this using this particular block diagram, right? That it will be as follows. You have a box A, and you have one force in this direction, and you have another force in this direction, right? F friction. That's it. So you just think about any object as a block, okay, and you just represent the forces as vectors, right? So how do you represent the force? How do you represent a force is as follows. You represent a force as a basically vector, right? This is a vector. This thing is called the head. This thing is called the head. And this thing is called the tail, right? This is called the head of the vector, right? And why do we use a vector arrow to represent the force? Since this force is a vector quantity, right? Why is it a vector quantity, Rupa? Why is force a vector quantity?
Because it has a direction.
Yeah, it has a magnitude, it has a unit, and it has a direction, right? Right? This is basically why we use arrows to represent forces, because it will have a particular direction. It has, let's say, if I just say this force is 5 Newton, right? So this is the magnitude. This is the basically the unit of the force, and this is the direction of the force, right? That is why it is a vector. Okay. I have some comments over here. Yeah, I will discuss this about the book after the class, right? So no worries. Okay. So is this clear? If any section is unclear till here, so let me know. Otherwise, give me a thumbs up. If all content covered till here is clear, give me a thumbs up quickly. Rubako, it's clear. It's clear to Hamza, it's clear to Varda. Azan is here, okay. It's clear to Ruba. Azan, try to make sense where what we are covering. You can watch the rest over the recording, right?
Okay.
Is pushing someone also comes in thrust? Yeah. So we are providing a push for the object to move in that direction. Yes, Mushal. Maybe is it clear?
Yes, sir.
Okay. Quickly use some Zoom tools. Okay, ताकि I can just quickly get your feedback. Okay. Okay, so now since we know all the types of forces, right? We know what are forces. Force is a push or a pull. We have discussed the types of forces. We have magnetic force, we have electrostatic force, we have gravitational force, right? And then we have contact force. We discussed about the resistive forces, which tries to oppose the motion, right? That is air resistance and basically drag of water. Thrust is basically the push which is driving some object, right? Either your body or your car. Okay. And how do we represent force? We represent force using a vector that is as follows, right? And how do we draw the free body diagram is as follows, right? I hope it is clear. We will do some examples in the next slide so it will make more sense.